All
Okay,
right.
cool. So I gave the students, kind of introduced your work and your profile on LinkedIn with the students. So they've gotten a little bit of an overview. But I will start with, or why don't we start with, however you want to introduce yourself to start with. I'll just let you take it from here, huh?
Absolutely. Yeah, so first of all, let me say thanks, Susan, for inviting me here because I really love to have um, any chance to talk about accessibility with folks because I think it's a really important uh, topic for both abled and disabled folks, and one that often doesn't get a lot of attention until something has gone horribly wrong. But in any case, I'm Dylan Fox. I'm the director of operations for XR Access, which is a research initiative at Cornell Tech focused on making virtual and augmented reality accessible to folks with disabilities. So today, we're going to go through a little bit about what accessibility means, because I'm sure all of you are at least vaguely familiar with the concept, but it's good to dive down into some definitions. Then we're going to talk about what it takes to design accessible XR experiences, and then talk about a little bit about the current state of accessible XR in industry, and hopefully have some time in the end for Q&A. And as we go through, if I'll try to keep an eye on, I guess I keep an eye on Zoom chat, but those y'all aren't connected to that, are you? If folks have questions, definitely feel free to shout them out. And hopefully, yeah, we'll have time at the end to discuss what's most interesting because this is a very light touch on a lot of broad topics. So wherever we find our interest drawing us, we can chase it.
And Dylan, I've kind of got things set up, so if any of the students that have questions, you guys can come up and sit down so you can engage and ask your question directly to Dylan as well too, okay?
Sounds great.
Thank you.
Okay, so first of all, let's talk about accessibility and something called the curb cut effect. So there's a lot of different but related words that get thrown around here, and the three that we're going to focus on right now are accessibility, impairment, and disability. So accessibility means that something is usable regardless of ability, right? We all have different abilities, the ability to see, the ability to hear. Some of us may be able to see or hear much better than others, uh, but all of these are the abilities that we have. And accessibility really means that something is usable regardless of whether you can see, hear, move, you know, you have different kinds of cognitive processes. We really want something to be usable to as many people as possible. Now, an impairment is something that hampers our abilities, right? And that could be, something intrinsic or something external. For example, you could have your vision impaired because you lost an eye in a sword fight, or because it's dark and somebody turned out the lights, right? And an impairment isn't necessarily a problem. You may not be able to see when you're in your darkened room at night trying to sleep, but nobody really calls that a disability. A disability, at least in terms of the social model of disability, is a mismatch between ability and expectation, right? So, for example, uh, you know, folks in wheelchairs, as a rule, tend to hate it when you call them wheelchair bound because they're not bound to their wheelchair. Their wheelchair is the tool that lets them get around and explore and have independence. Uh, Being in a wheelchair is not in and of itself a disability, but being in a wheelchair when the only way to get into a building is stairs, that's when impairment turns into disability. So, with that in mind, let's talk a little bit about who accessibility is for. Because a lot of the times when people think about accessibility, they think about people with permanent impairments. So, for example, here we have Paralympian Ma Lin of Australia, who's a gold medalist ping pong champion, table tennis rather. And he lost his right arm at age 5 when he stuck it in a bear's cage at a zoo, which is really a thing. Listen to your parents when you're at the zoo. Um, and when a lot of people think about accessibility, they think about people like Lynn who have these permanent disabilities. But permanent is only one type of impairment, right? There's also temporary impairments and situational impairments, right? So you could lose your arm because it got bitten off by a bear, but you could also have lost access to your arm because it's in a sling or because it's busy holding something. And the thing to focus on here is the idea that accessibility affects everyone, right? Because even if you may not have a permanent disability, and I should say a permanent disability yet, because most of us will develop one or more as we get older. Um, all of us have times of the day when we have either temporary or situational disabilities, right? All of us have times when we're distracted, when we're using our hands or our eyes or our ears for one thing, and we don't have them as resources to put to another. And so, there's a great graph here I'm showing from Microsoft Inclusive Design that shows some examples of that. You might be deaf because you have permanent hearing loss. You might be deaf because you have an ear infection, or it might be deaf because it's a loud space and there's too much talking going on. But regardless, the tools for one situation will help uh, people in all three of those categories. And so that brings us to the curb cut effect, right? This is the idea. So first of all, curb cuts are the things that little ramps that lead from the street down to the sidewalk, or vice versa. And these were not always there, right? We're used to seeing them every day when we're out and about. But it took a lot of activism to actually get curb cuts in place. If you look at the disability civil rights movement, there's stories of Ed Roberts and his gang in Berkeley, like going around in the dead of night and taking sledgehammers to sidewalks, and then just putting ramps there and telling the city, like, we're going to keep breaking these until you put them back in a way that's actually accessible, that actually serves everyone in the community. And after all of this, after a lot of activism and protests and rights and legislation, we finally put in curb cuts. And we found out, hey, these aren't just useful for folks in wheelchairs. It turns out they're also useful for people with strollers, people with suitcases, people with dollies, bicycles, all kinds of things. And so the curb cut effect has come to be known as this principle of when we design for people with disabilities, we make things better for everyone. And that is a really important concept, that if you take nothing else away, take that. You'll find that products that we make to be accessible tend to be better than products that aren't, even for people that don't have disabilities. As an example, about 80% of Gen Z viewers use captions while watching television, right? Because even if you can hear, that doesn't necessarily mean that you want to have the volume up, that you have good verbal processing, that you have English as your first language, right? There's so many different ways that captions can help people, that even though it may have been only legislated that we need them for deaf people, you really find that it helps a lot of people who use the product, in this case, the product being TV. The other examples, there's keyboards. The actually first working typewriter was built in 1808 by a man named Pellegrino Turri for his blind friend Countess Carolina Fantoni di Fivizzano, because he could not read her writing for the life of him, and so he wanted to develop a machine that would help her to write legibly. Um, Texting, you look at the origins of texting and you can look back to the text telephone, which was made by a deaf dentist named Dr. James Marsters in 1964 to enable deaf people to type messages over phone lines. And it turns out sometimes it's a lot more convenient to type your messages than to speak them live, right? Thus, texting. Audiobooks. The first audiobooks were actually back in 1932 when the American Federation for the Blind had them commissioned on vinyl. So you had vinyl records of things like Shakespeare and the U.S. Constitution. And again, turns out we don't always want to read our books. Sometimes we want to listen to them, whether you're blind or no. And one last example, speech recognition was actually pioneered back in 1952 at Bell Labs, partially for disability rights activists like Margaret Frommer, who were paralyzed from the neck down and didn't have their hands to use to operate technology. And also partially it was enhanced by DARPA for use by pilots, because pilots also, as it turns out, have their hands full when they're piloting planes and need additional ways to interface with their technology. So every time you look at ways to make technology more accessible, more usable by everybody, we find new ways for everyone to use it, whether they have those disabilities or no. And then one more note in this vein is that making things accessible to people often makes them accessible to AI. Um, because I think one of the common complaints that I hear when we're talking about investing in accessibility is people say, oh, well, we'd have to redo our whole system in order to make this accessible. And it's not worth spending X dollars to make it accessible for just this tiny portion of the population. But it turns out that investing time into making things accessible often means investing into making them more modular, more flexible, more powerful, able to be put in and out in a variety of ways. And that often means you're not only making them accessible to people, you're making them accessible to algorithms and to artificial intelligence, right? And the example here was be AltSpace VR, a VR space that was doing very well, bought by Microsoft. Microsoft, of course, immediately shut it down. Thanks, Microsoft. But before they did, they put a lot of work into making captions available, VR captions. And the infrastructure for that is non-negligible. You need to have speech to text to capture what people are saying. You need to be able to put these kind of speech bubbles up in a way that is going to be accessible to people and render those. And a lot of work went into the system. But it turns out after all that work, not only did they have a captions tool, they were one API call away from having a real-time translation tool, which obviously opens up the power of language to a lot more audiences and made the tool a powerful international meeting space. And all of that work that they put into making the captions available was foundational to opening it up to other techniques like real-time translation. So I'm going to pause there because I hate to just lecture for 60 minutes in a monotone at you. Let's talk for a moment about what accessibility features that you all may think you have benefited from in the today or the last week. What are some things that you think might be accessibility features that you yourselves have used?
Come up to so that way he can hear you and you can introduce yourself. Do I go all the way? I have a hot spot for you.
Hi, my name is Jenna, and I use the handicap button to open doors a lot when my hands are full, which happens a lot.
Yeah, that's true. Yeah. Awesome.
Absolutely.
Anybody else? Well, thinking about the Audible, I am gotten hooked on that because I had eye surgery and my eyes were so dilated, I couldn't read or do anything. And so that was just a lifesaver for me to be able to listen to books on Audible. And now I'm stuck on it because I, can listen to things while I'm doing the dishes, that type of thing. So that's, yeah. But did I just take yours?
Yeah.
Oh, man.
You're good.
I was trying to fill space. What else? Anybody else? Yeah, we have one over here.
Come up there.
Yeah, if you don't mind.
Sure.
Yeah, we'll put you on the hot seat here.
I like that. So that way he can kind of see who he's talking to as well.
Hi, I'm Gooski. I use like the captioning that is accessible for Zoom as like a way to look back and take notes, so that I can like reference them later. Because as much as I do like the fact that we also have the recording, the live captioning, while not the most accurate, lets me basically filter through the presentation and find keywords for notes that are like the most important. So it cuts down on my like note-taking time. Instead of having to go through the whole thing, I can just look for specific keywords and get the answer like that, which I think is really useful.
Yeah, that's great. That's a really good. Any others? How many people turn on closed cap? I was surprised to see your statistics on closed captioning. How many people are using that for movies? Yeah, so quite a few.
And like elevators as well.
Elevators?
Yeah.
Yeah. Yeah, exactly. He just mentioned in the back elevators as well.
Yeah, absolutely.
Yeah.
Awesome. Well, let's keep moving forward. So let's talk. We've talked about kind of accessibility as core principles. Let's talk about how they can be applied to XR. How we can make accessible XR experiences. So first, there the web content accessibility guidelines, which are currently our kind of main web accessibility standards, have four principles that they like to lay out. That things are perceivable, they're operable, they're understandable, and they're robust. right? Perceivable means that you can perceive the system. So, for example, an image should have alternate text. Operable means you can operate on the system. So, if there's like a click target for something, it shouldn't be so small you have to be pixel perfect to click it. Understandable means the system should be able to be understood, have things like consistent navigation, and other just paradigms that we're used to so that we know how to operate it. And then robust finally means that a system should be robust to a variety of user agents, i.e., it should work across different browsers, across different platforms. It shouldn't just work only in one specific configuration. Um, and the key to applying all of these is modularity, right? And this is another one of those things that if you take away nothing else from the lecture, think about this, which is that when we use technology, what we do is we perceive what the technology is giving to us, whether through hearing, vision, touch, however. We understand what it's telling us and what we want to do based on that. And then we operate on the technology, right? We touch it or tap it or speak to it or enter in words on our keyboard in order to make it do what we want. And the key to accessibility is that making sure these things are modular, that both for perception, perceiving them and operating on them, there isn't only one way, one bottleneck that is the only way you can get information about them, right? So if your whole experience, let's take an example of getting a text from a friend and responding to it, right? You get the text, and that could be your phone ringing, and then you text them back. That could be just swiping on a keyboard, right? But instead of the phone ringing, it could also be a light that flashes. It could be a vibration, right? It could be any number of things. And when you're texting them back, that could be through typing on your phone. It could be through speaking the words, having text to speech. It could be any number of different operations. And as long as there's multiple different ways to get that input and multiple different ways to give that output, then that operation is probably going to be accessible, because there's no one way to do accessibility. Something that is accessible for one person may not be accessible for another, because every single person has a different combination of abilities. And so really the key to making things accessible is to make sure that people can customize it to their own capabilities for perceiving, for understanding, and for operating. Um, so that is definitely a big one. Another big one is the idea of nothing about us without us, right? This concept that even for accessibility experts, there is no replacement for lived experience, right? If you think something's accessible, but you haven't actually tested it out with folks with disabilities, it's probably not accessible. There's probably something you missed, some intersection of things that disabled folks will be able to tell you about. And so there's no substitute if you're trying to design something accessible to testing, and ideally having disabled folks in your design and development process as early and as often as possible. Okay, so with that out of the way, we said we were going to talk about XR. Let's talk about XR. So we're going to go down by vision, hearing, a few other types of disabilities, and talk about how we can make XR accessible for people with those challenges. So for vision, universally, to make things visually accessible, you want to have things like good fonts and high contrast information, ways to make it more easy to see. And then you also want to have things that will replace the visual input for people that cannot see at all, that are totally blind, right? The big one being alt text. If you are blind, you'll probably use a technology called a screen reader, which goes down and kind of reads pieces of a website out one at a time. And when it comes to images, it will read out the alternate text for that image. So here we have, a guide dog saying, "This is me pretending to be interested, and this is me not pretending," and that's what a screen reader would read out. Now, applying that to XR, there's a lot of different ways to do that, right? I have an example here from a Udemy plugin called Seeing VR, which was made 2021, I want to say. Don't hold me on that. But they had a bunch of different ways to enhance the visual experience for people that have visual disabilities. Things like magnification, edge enhancement, recoloring, text augmentation, where you take text and make it much bigger and brighter contrast, as well as things like object description and applying AI to just summarize the scene for you. Um, Again, this is a very deep subject. There's many, many, many academic papers on how we can make XR more accessible, how we can use augmented reality to make the world around us more visually accessible. So we'll come back to this, but there's definitely tools you can do to make something that a lot of people consider to be a visual medium into a more multisensory experience. For hearing, common things for 2D are, we just talked about captions. Those are obviously vital. There's also things like volume sliders, being able to control sound effects versus music separately, being able to manage the volume of different elements and the other kind of sound aspects. And these all very much apply to XR, but there's also new challenges. So when we think about captions in XR, this is a GIF that's playing from Alchemy Labs Vacation Simulator. And you can see it's not as simple as just putting captions across the bottom of the screen, because you don't necessarily know who's talking, right? They could be to your left, they could be to your right. That's information you're getting if you're hearing them because of spatial sound. You will hear where the person that's speaking is. But if we want to have an equivalent experience for people that are deaf, we need to communicate that through our captions. So here they have a little icon indicating who is speaking, a little arrow that points to them, and this behavior of, if you're looking in the speaker's direction, the captions kind of dock to them like a speech bubble. But then if you look off to the side, it needs to move with you and for you to be able to keep your eyes on it. Otherwise, they could be talking to the left and having a speech bubble over their heads, and you never know it was there. There's also challenges with, opacity, like what happens if I put my hand in front of the subtitles? Does it show up through my hand? We had a great talk at last year's XR Access Symposium about that from the folks at Alchemy. So that's something you're curious in, make sure to check that out. When it comes to kind of physical motor disabilities, there's important elements like making sure you have, as I said, big touch targets, having alternatives to touch, like using voice commands, being able to say the keywords you're looking for instead of reaching out and touching them. And again, related to screen readers, there's this concept of tab order, where you should have a clear. There should be a way to just basically tab through elements. Go through tab 1, 2, 3, 4, 5. Those should be in a sensible order, and then you should be able to just tab to where you need to get, and then use enter or other keys to interact with it. That's something that both people with motor disabilities and people with visual disabilities are going to be using. Gets a lot trickier when you take it into XR, but we do have folks that have been experimenting with that to great effect. When you think about physical disabilities in XR, though, there's obviously additional challenges, because one of the best things about XR, particularly VR, is in some ways you're reducing the levels of abstraction, right? If I'm playing a Legend of Zelda on my Switch, I press a button and Link swings a sword. But if I'm playing some type of swords and sorcery adventure in VR, maybe I just swing my arm and that swings my sword, which is awesome in many ways. But we have to make sure that the folks that have physical disabilities who may not be able to have that range of motion still have access to those games, to those experiences. What I'm showing you right now is a tool called the Walk-in VR Driver, which lets you do all kinds of things in terms of co-piloting with an able-bodied person, virtual motion and rotation, so you can have for example, if you only have this much range of motion, the controller can automatically kind of expand that for you and magnify it. Or conversely, if you have spastic motion, then it can smooth things over, right? And so being able to take into account people's ranges of motion and accommodate those is the type of thing these tools need to be able to do. Also things like position adjustment, and also tracking of hands for people that can't hold controllers at all. There's a lot of folks that can't, make a fist for long periods of time, operate, two thumbs, two hands, and so for those folks, we need to have non-controller based means of interaction. And you can think about this not only in terms of these types of external tools, but also in terms of design for experiences themselves. Um, this is a scene from Half-Life Alyx, which is a really great VR game, although not one I would recommend for people that don't like jump scares. And a lot of VR games, especially early VR games, suffered from this experience of, oh, I dropped something on the floor. Let me just like get down on my hands and knees and try to pick it up with the controller and hope it hasn't like slipped below the plane of my floor. Um, really annoying, frustrating experience, even if you can get down on your hands and knees. Um, if you can't, then that could just stop your experience altogether if you drop some important object. But what Half-Life did is it has these things called the gravity gloves, where you can just, as you see here, kind of with a flick of the wrist, drag objects straight to you. And that is not only a really awesome experience for able-bodied players who can feel like a Jedi, but a more accessible experience for people that can't physically go and pick those objects up off the ground, which is what a lot of those old school VR games asked you to do. So that's just another example of the curb cut effect in play. Um, Talking about cognitive, now cognitive accessibility has a lot of overlap with just good UX design, because again, the ways that people think and process information can be very varied, and so something that helps you out is going to make it lower kind of stress and lower cognitive load for everybody. But some of the things that you might do in both 2D and XR are things like having contextual help options. Don't have one tutorial, expect everyone to memorize it and then go on without references. Let people get the help they need when they need it. You can also have things like Google Tilt Brush has beginner mode, where it hides a lot of the controls until you're ready for them, right? It gives you just the basics at first. And then once you've mastered those, you can command it to expose all the extra features. And that limits the amount of cognitive load that you're being faced with at one time. And related to cognitive, there's also the idea of sensory overload. A lot of people can get very rapidly overwhelmed or overstimulated. There's also certain people that may, have epileptic seizures. This tool on the right is something from the Trace Center. That's a photosensitive epilepsy tool that will scan a clip and see if it's has enough big bright flashes that it could potentially provoke a seizure in someone. And so just making sure when you're designing your experiences that you have ways to limit those extra animations, to limit those extra sounds and other sensory inputs, and really bring something down to a more kind of serene, less stimulating, flashy experience is going to be really important. I have a cautionary tale here, which is a short film called Hyper Reality. And you could tell, especially when you have multiple AR apps competing for your attention, just how overstimulating that can get in a hurry. When you have the real world's every single thing trying to show your advertisements, all of the above. We need to be very careful with how we ask attention from our users. Okay, so let's pause again and chat, because you all are taking a course on XR. I would love to hear what some of your favorite applications are, what accessibility features you've seen, and what accessibility features you think maybe they should have. Either things that you have struggled with directly while using the apps, or something that you think might open the experience up to more people.
I think we have a real mix in the classroom in terms of people's experience with XR. Some have very little, some have quite a bit. But anybody want to jump in here? Thoughts? Huh, Fabley?
Well, maybe a quick show of hands. Who has tried virtual or augmented reality before? Yeah, okay, most of you. All right, so let's hear about your
Okay.
favorites.
I actually have been trying to show them some AR stuff, and then we'll be exposing them a little bit to some other experiences as well.
I personally like the cyber sickness option where you can, after every 30 minutes, it's like, oh, take a break from it. And the other option where instead, like, of making sure that things are moving too quick, you can control how quickly things are moving so that you don't get motion sick.
Yeah, that's a
Yeah,
big one.
absolutely. No, cyber sickness is a huge area of study. There's a lot of like cockpit modes and different things you can do to kind of mitigate that. So that's a good one.
Yeah. So what experiences have you guys engaged with?
I played Hitman on my nephew's PS4,
Uh-huh.
and that was a really weird one because without standing up and not having a lot of space, just sitting down, I was able to play without having to walk around, which was nice. It was a little queasy,
Yeah,
but
but it brought kind of a consciousness, it sounds like, to, the idea that if you aren't able to move around, that
Yeah.
you can, still enjoy the game.
yeah, you can still enjoy that while being like fully seated or like stationary in reality.
What other games you guys play?
Went to those VR game room.
Mhm.
So they wear like the glasses and you basically hold on like some sort of plastic thing, but in the actual like the VR environments, like gun or like weapons you going to use in the game setting.
Mhm.
It's kind of like fun, although it's really heavy when you wear those like sensors and then the glasses. So there's like headsets on the top, and then there's like I think there's one game room I went to is like I wear like vestes and everything is like pretty heavy.
Yeah. Did you hear that okay, Dylan?
A little bit of it. Which game was it?
So she was saying she's been to some of the game rooms. And
Mhm.
so in playing certain games, especially kind of a shooting game, that the devices themselves are very heavy. So the actual headset and the actual gloves that you might be wearing, or a haptic vest that you might be wearing, she's saying is very heavy. So you're taking it from a position of just the actual devices themselves and the physical experience of the devices.
Absolutely. And that is a big concern. I think there's a lot of people that, you know, out of the box cannot use some of these headsets, right? Either because, like I said, there's weight concerns. There's a lot of folks who may have big hair or religious headwear that cannot fit the headsets over those, which is certainly something that we could design around if we put our mind to it. Um, so yeah, the physical, the design development of the hardware is just as important as that of the software for sure.
And I think getting back to what you're talking about in terms of its, accessibility for all is, I can only be 20 minutes in a headset before I start getting a headache. So I have to really pace myself. And I just now bought a new band that's apparently going to be able to help with that a little bit. So I'm excited about that. But I think that's also an issue too, I found.
Yeah, definitely.
What else? You guys had your hands raised in terms of experience XR. What AR or VR experiences you guys played with?
Like my younger brother has a VR headset, so not too many. I was honestly more geeking out over the interface when he was showing me. There was like a feature, there was a feature he had where he was able to like switch like to different like rooms for like just the whole menu.
Yeah.
And I was just
Yeah. So that's a good point as well, too. She's talking about, having engaged with her brother and his headset. He was showing her how they were then in virtual reality moving from room to room. So being able to switch from space to space. And so I think, that's also, consideration in terms of how accessible that is.
I think what was cool about that is it was like the interface layout, like you could just do that while just sitting down, like we didn't really have to move around too much for it.
Yeah. So she was saying you didn't have to move around too much with that as well, too. This is why
Yeah,
I want
absolutely.
forward so that I don't have to interpret.
Yeah.
But then thinking about it too, think about how you were actually having to engage your hands with that. Did you feel like, could you see that as being maybe a stumbling block in some instances?
I will say without like the remote, the hand detection wasn't always like very precise.
Yeah.
And, the remote, it's like a separate piece that you need. Sometimes it's like, and for some people, like they're not used to that. So I would say like maybe improvements on just the basic hand detection would make it a lot more accessible and a lot more obvious.
Did you hear
Yeah.
that okay?
Yeah, I was able to hear that. I mean, let me ask you all, how many of you, show of hands, feel like you would feel comfortable just taking your parents or your grandparents and putting them in a VR headset and letting them just like be confident that they could figure it out without help?
They're all laughing.
Right. And so that is exactly something that shows we have a long way to go, right?
Yeah.
Because in a perfect world, that's exactly what you could do. You could give people the headset who don't have that training, who don't necessarily have that sharp vision or hearing or mobility, and they'd be able to pick it up and use it. And the fact that everybody's laughing at that shows that it's really in many ways still kind of an immature technology, right? We still need to make those advances in the hardware and the software in the user experience design in order to make it a really welcoming and accessible technology.
Getting
So
back to my situation, I have now a different, my eyes are very different in terms of the focus. So when I go into VR headset, I actually have to take my glasses off in order to be able to see in the headset. So I know that they now are starting to make different lenses that you can put in the headset to help people as well too. So if you have prescriptions or, different circumstances in that regard too.
It's very useful.
Yeah.
yeah, there's actually I remember seeing at AWE last year a company that's making these almost like bifocal style lenses where you can set the prescription to like a whole range of things, and they just kind of sit in the headset, which I thought was really cool.
Cool.
I'll see if I can fish up the link later.
Okay, great.
Okay, well let's go through our last section here, and then we'll have some more time for Q&A, because I want to talk just a little bit about accessible XR in industry and some of the tools and apps that we're starting to see come out. And this is really just kind of a sampling, but if y'all have particular use case you're interested in, let me know and we can dive in. So one of the big ones when we think of XR as an assistive technology is the idea of sighted guides, right? So if you are blind and you come to a new space, oftentimes what you'll do is you'll ask for a sighted guide who is a person who can volunteer to basically guide you around a space, answer your questions about the environment, all that kind of thing. And we're starting to see technology that can do that more and more. So, for example, there's a company called Be My Eyes who became very successful a few years ago by letting people all over the world volunteer or request assistance as sighted guides just over the internet. They've been experimenting with something called Be My AI, where you take a photo and then you can just have a talk with a chatbot about what's in the photo and help it kind of understand your environment and help you achieve your goals. And that is definitely like an AI plus augmented reality combination that is been really powerful for a lot of the blind folks that I've been talking to, because you don't always want to wait for a volunteer. You don't always want to have things that have another person on the end of the line. There's a whole nother question here about data privacy, but we'll table that one for now. But that's very important not to lose sight of as well. Another example on the right here, we have a company called Glidance that has, I think they're in the process of making a guide robot and wayfinding AI. And this is something that I just learned about like a week ago from some of the folks in the blind community I talked to. And it is basically kind of a little robot connected to a handle that you push along. I know it looks a little bit like one of those like Fisher Price toy carts, but it's potentially got some very powerful features, right? It's got a camera that can look at the environment. It's got these because it has a physical element to it in terms of the wheels. Those wheels can turn left or right to keep you walking on a straight line, which is a big challenge for a lot of blind folks. It can brake, if there's traffic. It has all these capabilities to help you kind of guide you to your destination. And that is just one of the types of products that has been coming out trying to leverage all of the technologies that have been making AR possible. So very, very exciting time in the kind of accessibility technology space. And very good space for people that are interested in entrepreneurship to think about, because a lot of these technologies, they come out and a lot of people will think about, how do I make the best Instagram snap, or how do I solve some very like first world problem? But there's not a lot of people that think about the accessibility applications of these technologies. And so there tends to be very big opportunities for, entrepreneurs to come in and apply modern technology to kind of classic problems of accessibility. Some more examples of things we're seeing: brain-computer interfaces, right? You have on the left here Cognitions with an X, Cognition One brain-computer interface, which is a headset that is designed for people that are very severely disabled in terms of motor disabilities. People that can't move from like the neck down, people that can't speak, and a lot of these people that have had to do these like incredibly so slow process of like moving their eyes left and right to select things. They've done a lot of work in terms of streamlining that, using brain computer interfaces to be able to kind of tell what they're thinking, and translate that into communication, into control of smart devices, and all kinds of other applications. So very, very science fiction, very much the type of thing where if you had, that disability of being able to move nothing but your eyes, or maybe not even your eyes. There's people with locked in syndrome that can't move anything at all, but are still thinking. We're finally getting to the place where we have technologies that can help those people leverage their communication skills and leverage smart homes and smart technology to be able to have more control and more independence than they've ever had in the past. On the right, we have the Meta Surface Electromyography, or SEMG, wrist controller, which is a brain controller interface in the sense that it is, rather than having you operate buttons, it is reading the nerve signals that are sent to your hand, which means that even somebody who doesn't have a hand can, flex like they are, pinching their fingers or doing something else. Those nerves are still there. And so it can register those movements even when there aren't any actual movements to register, which is absolutely wild technology. And again, something that it could make a very big difference for both people who have limb differences like this, but just also in terms of meaning that you don't necessarily have to have these controllers that occupy your hands and dangle and smack and get in the way, but that just we can basically think and have these machines interact with us. Just again, very powerful in an accessibility context, but also just a general kind of user comfort context. There's also a lot of, in terms of the actual applications that virtual reality is being used for, there's things like physical therapy, right? Physical therapy is always a pain, because for so many people, it's hard to measure if somebody's doing something correctly. Unless you are a trained physical therapist and you're in the room watching the person do the exercises, it can be very difficult to know whether they're doing them correctly. And B, it can get very boring to do these, often painful exercises over and over again. And virtual reality can help solve both of those, right? We have a screenshots here from one company called Neuro Rehab VR, another one from a group called Emergo, who has this embodied telehealth project, where virtual reality can both track your motion better because you have, the controllers or other just motion sensing that's telling you, for example, exactly how high the patient is raising their arms, and can also let you both communicate with doctors remotely, so you can do it from your home instead of going into a doctor's office, and make it more entertaining. You can gamify these things and turn it into any number of different types of experiences instead of just sitting in your living room and raising your hands like a chicken, right? um, so this is the type of use case that I think we've been seeing a lot of success in. I know VR has gone kind of up and down in its hype cycle. There's things like the metaverse that haven't always materialized as people have predicted they would. But there really is, for things like physical therapy, for things like training, a lot of applications in healthcare and pain management. There are places where virtual reality, especially, has really taken off because it offers things that no other product can. And so if you're interested in looking into, VR XR as a career, really think about things like that. Think about where it can provide that value that nothing else can, and try to capitalize on that and try to design in ways that people haven't, to make life easier for folks with disabilities. Because there's a huge opportunity to do that with these technologies that a lot of people just aren't capitalizing on yet. Oh yes, and then one shout out I wanted to make in terms of hardware and kind of operating system accessibility is the Apple Vision Pro. Um, there's a person here, Ryan Hudson Peralta, runs Equal Accessibility. Asks, how accessible is the Vision Pro? Can you set it up without hands? Answer: not quite. Still not quite. There's crowns that you have to press on the device in order to activate some of the accessibility features. But that being said, the Vision Pro is still one of the most accessible headsets on the market. I've got a picture of their accessibility settings here, and not only does it have things like VoiceOver, and that's the iOS screen reader. A lot of the other screen reader or accessibility features ported over from iOS. It also has things like eye input. Is it looking? It uses a lot of eye tracking, but is it using both eyes? Is it using just your left eye or just your right eye? And you can also set it to instead track your finger, or if you can't do your finger, track a wrist. Um, it's very modular. It's very adaptable to what people need. There's shortcuts you can do, like taking certain types of gestures and mapping those to a sound. So instead of having to, poke something, you can just look at it, and like click your tongue, do whatever else you want that you've set it up for. So it's not accessible in that it still costs about $3,500, which is not a very accessible price tag. And there is a whole other dimension of accessibility in terms of things like internet access, price, durability that we haven't talked about today. But it is definitely one of the more accessible headsets out there. So I could go, much deeper into any of these, but I want to take the rest of the time we have here to stop for some Q&A and hear from you guys. What is it that you're interested about when it comes to XR, and what questions can I answer for you?
Thank you, Dylan. Any initial questions? Oh, come on down.
Yeah. Hey, I'm back. So I wanted to know a little bit more specifically about AR and its applications. We talk a lot, very commonly about VR, and XR, even if XR isn't necessarily referred to in that way. There's always a lot of conversation about XR and VR, but AR doesn't seem to get like a ton of conversation or really application about it. The one big one that I could really think of was the like Apple goggles that you just showed, and then some stuff on our phones. But aside from that, I can't really think of big examples or applications of it. So I'd like to know more about that.
Absolutely. So AR, I think, is a very powerful tool that we definitely haven't explored to its fullest yet. Um, the thing about AR that's so exciting is there's a lot of data in our everyday environment, and we don't necessarily think of it as data, right? But like, I'm looking at somebody's water bottle, this white water bottle that's on the table in front of me, right? The fact that that is there is data, right? Its position is data. What it's made of is data. If it were making sound, let's say there was a swarm of angry bees inside, that would be data, right? And that data is accessible by default to people that have, their vision and their hearing and so on and so forth. Um, but what AR can do is make it accessible to people that don't have those senses, right? If I am blind, I can have an augmented reality application either through my smartphone or through a set of glasses or whatever else tell me, hey, there's a water bottle on the table in front of you. It's white, it could probably hold about this much water. It sounds like there's a horde of angry bees inside of it, so maybe don't open it. Right. It can take that real world data and translate it in a way that nothing has in the past, right? You would have needed either to run up and like touch it or listen for it or have somebody else tell you it's there. And the possibilities for that in terms of taking audio data, taking visual data from the real world, taking text on a wall, on a poster that is not digital anywhere, and turning it into data and then making that data into something that is accessible regardless of ability, I think is immensely powerful. And it has the ability to make the real world accessible in a way that many technologies that are focused on kind of the information world, the cyber world, have not. So I think that is one of the big opportunities for AR that really is only beginning to be explored.
Questions? I feel like the price is right. Come on down.
Come on down.
Hello. So my question is like, what do you see the world as? Like that hyper reality video that you showed, or like everyone has Apple Vision Pros or Google Glasses?
So in terms of like adoption going into the future, right, is that kind of what you're
Yeah.
asking? Yeah. Uh, I see there being uh wearables in the same way that different people have like things like the Apple Watch, smartwatches, right? What I would love to see is not necessarily like everybody has a headset and it's always on all the time and everybody's tuned out of reality. What I would love to see is these kind of multi-purpose platforms that you can wear if you are, abled and you just want to have more information about your environment, more ways to interact, or if you're disabled, it can have all of these accessibility tools built in, right? Because if you look at assistive technology, there's been many, many years of kind of single use assistive technology, right? For example, there's a piece of tech called the OR cam that for 10, 20 years, it's a little camera that you can attach to your glasses, right? And if you're blind or low vision, it can sit there and like, oh, I need to read the newspaper. I can tap it and it'll read it out loud to me. Or, oh, I need to, determine what type of dollar bill this is. It'll read it out to you. The challenge is when those assistive technologies are basically just that, assistive technologies, you get a lot of stigma because if somebody walks up to you and they have this weird thing clipped to their head, you're like, what the fuck is that? And a lot of people who are disabled don't necessarily want to broadcast the fact they're disabled by using these, weird intrusive technologies. But you look at a smartphone. Well, everybody's got a smartphone. If you're disabled, you pull out a smartphone, nobody thinks twice, even though you're using this technology that maybe other people don't have to use because they can just read what's there already. It also makes it so that instead of having all of these like single use, really expensive gadgets that each one does one thing, you have this one computing platform that can do it all, right? A smartphone can have any number of different assistive apps on it, as well as all the apps that everybody else uses every day. And so we can build out these kind of general purpose computing platforms that can interact not only with the environment, not only with assistive technologies, but with mainstream applications. I think that opens up a lot of doors for folks who have disabilities. And so I think in going into the future, if we could have these nice kind of low cost, maybe $100 or $200, maybe subsidized for people that can't afford it, off the shelf technologies that also have all of these accessibility tools built into them, I think that's going to be a much more accessible future than the one that we have now.
Thank you.
Anybody else? I think we're starting to run out of time. Go ahead.
Hi, my name is Noah. Thank you again for presenting today, by the way. Everything has been super interesting so far. For a little bit of context, RIT has a lot of deaf or hard of hearing students. I was interested in, sorry, there's not a lot of good headsets or technology that works well with hearing aids or cochlear implants that I've seen. I'm not personally deaf or hard of hearing, but I have a lot of friends on campus who are, and they have expressed as such. So I was curious if you knew of any technology currently or any tools that you would integrate into an XR experience that would either promote usage of this technology instead of hearing aids or cochlear implants, or works well in tandem with it, because so far I have not seen anything.
Gotcha. Yeah, I mean, I think with hearing aids specifically, I believe Apple has started basically making the it was AirPods, earbuds, whatever those are, be able to function as hearing aids in part. I'm not sure of the details on that if you need specific ones, but I know that is the type of thing that is starting to happen, and I think it speaks to the importance of needing to have these assistive technologies talk to other technologies like VR headsets, right? They need to be able to operate via Bluetooth or other kind of common tools to be able to connect and work together. I, in terms of kind of hearing use cases off the top of my head, I believe there's, yeah, some other ones that utilize Bluetooth that could theoretically connect to that so that you could I think for the like the Meta Ray Bans, for example, you could have it use their built-in speaker, but you could also have it go through Bluetooth, for example, through Bluetooth enabled hearing aids. There's also some interesting work being done, at Gallaudet University. They have some work going on with sign language and XR. It's very difficult to just take sign language and translate it, but it's definitely a problem that they're working on, as well as using VR for training, because it's a lot easier to learn sign language when you have something where you can actually, have it be registering what you're doing with your hands, and giving you feedback on whether you're doing it correctly or not. And I know as well that there are uh, groups working on real-time captioning, right? So, if you're totally deaf, maybe audio aids aren't a good use for you, or you want to be able to use your hearing for other things other than understanding speech. There's both glasses that will capture audio and then display them as captions, or if you don't want to have the onus be on the deaf person to have the technology, there's groups working on things like badges. Let's say you're a doctor and you're working with a number of deaf patients. Well, rather than giving every single deaf patient a headset, captions glasses, you have a badge that takes what you're saying and writes it out, so that if somebody is deaf, or if somebody is speaking a different, has a different language, you can set your badge to display in a different language instead. And so it's important to think about that stuff as well, not just having the onus be on the disabled person to have technology that enables them to coexist, but on our systems and our service providers to be able to do that as well.
Thank you. We will also be visiting Wendy Daniels is in NTID. She's the director of their XR initiative. So we'll be doing a visit to her lab, and they're doing some work as Dylan described in terms of using captioning and being able to see the interpreter and in single line sight with whatever, performance maybe that they're seeing as well too. So some really interesting research they're doing there. So we'll be visiting their lab as well this term.
Awesome. Thank you so much.
Yeah, there's a great paper called Chat in the Hat that was like this headset, I see a little interpreter in the corner and they like speak out through my hat. That was very fun stuff there.
Yeah. Oh, cool. I love it. I love it. Wonderful. Well, thank you so much for your time. It's always very informative and awesome. Oh, here you go. A last information.
Yes, so just a couple of links to leave y'all with. We have a GitHub. If you go to xraccess.org/GitHub, there's a lots of resources there in terms of design development. You can also reach me. You can go to our website, xraccess.org. I'm just Dylan at xraccess.org. And definitely feel free to reach out on LinkedIn and connect if y'all are interested in kind of getting into the XR industry. I'd be happy to chat and try to at least talk about the accessibility side of things. I'm always trying to keep an ear out to the industry side, but I tend to live more in academia than that. But would love to talk regardless. And yeah, hope y'all are starting to kind of think about, wow, how can all this stuff be applied to accessibility as well?
And I really appreciate, we're kind of starting off our speaker series with you, which I really love the timing because then I think it enables us to be able to talk to the other speakers about how they're incorporating access in their fields as well too. Cool.
Absolutely.
Thank you very much. Really appreciate you coming in. And I will chat with you later.
Thanks, Susan. Have a great one all.